My name is Richard. This is the first time I've been in the Ukraine, so thank you very much. I'm going to be speaking a little bit about Java 8, and in fact I'm the author of a Java 8 book. Interestingly enough, even though this is the first time I'm in the Ukraine, the book has preceded me and already been translated into Russian, so that's fantastic as well. The title of this talk is pragmatic functional refactoring with Java 8. So what does that actually mean? Well, historically, when we think about functional programmers, we think about people like this guy. This guy's an academic, okay? You can see that because he's got a massive, huge, shaggy beard at the bottom, and he's also incredibly sad and unhappy, okay? Not a day-to-day developer, academic lecturer. Whereas most of us look like, Emmett from the Lego movie, okay? We've got a job to do, we've got to get on with things, and we've got to achieve kind of day-to-day goals and get stuff working and get code shipped. So, how does functional programming concepts benefit us for actually solving kind of ongoing business problems, doing our day-to-day development? How does that actually help? And specifically, how do the functional programming features introduced in Java 8 help us achieve these goals? So, this talk's going to go through a few different kind of concepts from functional programming. We're going to talk about first-class functions, currying, immutability, and optional data types. And we're going to talk about how you can use each of these different features in your day-to-day code and how they can help you. So, first-class functions, what's that all about? Well, let's suppose you're kind of running some kind of business, and your boss comes along to you and he says, find me different invoices from Oracle. Find me some money that were coming in from Oracle. So first of all, that means you've done a fantastic job, because it means you've forced Oracle to pay you money, which is an achievement in and of itself, but standard business reporting. So you might write code that looks a little bit like this. You take in your list of all your invoices, you loop over them, you check whether the customer involved is Oracle, and then if so, you add it to some results list and return that list of results. Well, as your boss is prone to do, the requirements change, right? And they say, what about if we want invoices from other customers? Maybe we've picked up Google or Facebook or whatever as a client. How are we going to filter for different things? So you abstract over that customer, okay? You put a parameter in to say what the customer is, and you can then check that if statement against the customer. That's fine if all you want to do is filter the customer. But over time, your requirements change again, and your boss says, I want to find invoices with something in the name. Maybe they had training in the name, or consulting in the name, or development in the name. So you'd have to go and write another function, right? You'd have to have a completely different filtering operation. And nearly all of this code is the same as on the previous slide, yeah? You're looping over that list of invoices again. You're making some kind of check about an individual invoice, and if it meets that criteria, you're adding it into your list of invoices. The only thing that's different is the idea of this filtering condition. Now, I'm not recommending you write code like this, but a naive attempt to reuse that kind of code may involve writing something like this, some kind of flag to say, are we checking for the type of customer, or are we checking for that property on the name? Who likes code that looks like this? No one. This is terrible, right? Fantastic, we're all on the same page. So let's step back a sec and see how we can think about things a little bit differently. Well, we could say we're going to model that selection criteria. We're going to model the thing that says, is this an invoice that we're interested in or not? And we're going to have an interface here called a predicate, and that is something that's going to return us true or false, depending upon whether we're interested in that invoice. Okay? Then we can rewrite our finding function to be like this, okay? We can take that find invoices, and instead of having to copy and paste all the code, just changing that one little bit, we can call the test method on our predicate, and apply a different filtering criteria as we go along. And we can use our code like this. So we've got our Facebook training or whatever our criteria is, and we pass that in as a parameter, and we've got that class. But that approach of having a new class every time you wanted a selection criteria ends up being very verbose. It's very problematic. It's something which discourages us from writing this more elegant, more generic code. Now, Java 8 introduces a feature called method references, and method references, those guys at the bottom with a colon, and that means generate me a predicate that just refers to this method. So our Boolean method saying, is it an invoice related to Oracle, or is it an invoice related to training, can just be passed in using a method reference there. Lovely. We can also use the lambda expressions feature that's been added to Java 8. So with lambda expressions, we pass an anonymous function in that just says, take this invoice and apply some expression on it, something that returns a Boolean, is it true or false? And lambdas here have let us have that same very generic code with just a different filtering criteria, but do it in a much more convenient, less verbose, easier to read way. So, this is really what we mean by a first-class function. It's the ability to take a function that was either an individual method or was a lambda expression that was an anonymous function, and pass it around like a regular value, pass it as a parameter into a method, store it into a local variable. That's really all people mean when they say first-class functions. And it's actually related to an existing concept which you're very familiar with in object-oriented programming called the function object. So design patterns like the command pattern often generate you function objects that try and emulate these functional programming features. And we showed how you can use lambda expressions here to cope with a requirements change. So instead of having to copy and paste a load of code and rewrite it all the time, we can just pass in a different strategy, and we can conveniently use it with either method references or lambda expressions. Okay? Okay. Who's a fan of Lego? Fantastic, fantastic. I've got to, ask a few people this. It seems to me there's a really strong correlation between people who played with Lego as a kid and people who were professional software developers when they're grown up. So Lego has this great property that you can take individual blocks of Lego and you can put them together to build more complex, more interesting features. And functions have the exact same characteristic. Once we've said we've got first-class functions, that they're genuine concepts, we can start putting them together to do more interesting things. So, with our example from earlier, so here we've rewritten the code to use Java 8 streams. So we're going to take a stream of an object, we're going to filter those values again by some predicate, and then we're going to build up a list at the end. But we've got here two different choices. So the first one is taking the predicate that says it's a Facebook invoice and then composing it with another predicate that says it's a training invoice. So we've put those two predicates together by saying and this. And the second example is something where we've said, is it a Facebook invoice or a Google invoice? So those are examples of how you can compose functions. But don't worry, there's no craziness or magic. The implementation for these approaches to composing functions is very simple. So here we have the implementation of our predicate interface. You'll notice, if you look at the JDK source code, that it's very similar to the implementation in Java 8. But obviously, for copyright reasons, it's not the same code. Okay? So what we've got here is an implementation of a default method with our and all that's doing is using the lambda expressions feature to return a new function back that calls itself and calls the other predicate that we've had as an argument. And the implementation of OR is doing exactly the same thing. It'll test itself, referring to that implementation on the interface, or it'll call test on our other predicate. So you can compose together functions very easily in very obvious ways by just implementing these default methods on interfaces, which, by the way, is another Java 8 feature. Interfaces can now have method bodies in. It's also possible to use function composition to build up pipelines of functions that go one after another. So here's an example of us doing some email processing. So we've got our email, and we're going to have some common functionality. Maybe we're adding a header, checking the spelling, and adding kind of a signature at the end, okay? And you might be able to put together a function composition pipeline by using this and then method. So what this says is it means take the first function, and then take the output of that and pass it as the input of the next function, and then take the output of that and pass it in as the input of the third function. And why won't you want to do this as an approach of function composition rather than just calling them one after another? It's because it gives you a little bit more flexibility. So here's an example of we're taking our processing pipeline, which is going to add the header and then check the spelling and then add the signature. But I could just as easily build up a simpler pipeline that adds the header and the signature but doesn't change the spelling or doesn't change the body of the method. So by taking individual small functions that we can compose together for reuse, it gives us more flexibility when building these things up in a pipeline. So that was first-class functions. Let's talk a little bit about currying, shall we? So before we explain what currying is, let's just think about a simple example conversion function. So this is a function that does a kind of a linear conversion, y equals mx plus c type stuff. So you bring in an amount that you want to convert from, you're going to multiply it by some factor, and then you're going to add a base to that factor. So for example, we can use this to convert temperature by taking a factor as 1.8 and a base as 32, and then we can convert from Fahrenheit to Celsius. Okay? Fantastic. But we might want to use this conversion function for different things. So, as I say, we could convert our temperature. We can also convert currencies. So there's a dollars to pounds conversion. Obviously, don't hard code currency constructs in your code. This might well have been how the 2008 financial crash happened. Who knows? But it's just an example of how you can use that same conversion function. You can also convert from kilometers to miles by having a factor of 0.62 and a base of 0. So there's another one there. But in all cases, we've ended up kind of reusing this in a bit of an ugly way, passing in the constants separately. So what's the problem? First of all, we want to be able to abstract over the idea of here's a conversion function and pass in different conversion functions. And the other idea is we want to be able to reuse it. Now, in this case, it's only a very, very simple method because it's just a simple example that we want to put on a slide. But you might be able to think about how you can use this for much more complicated methods where you do really want to reuse the body of that method. So, curry. My favorite type of curry is the thali. Thalis are curries where you get lots of different small dishes and you can put them together in ways that you want, which is a bit like the concept of currying from functional programming. To curry a function is to transform it from a form in which it takes all its arguments as one monolithic argument list into a form where it takes one argument and returns you a new function that takes one argument and returns you a new function that takes another until it's down to only one argument at the end. So that's what currying is about. So how does that apply to our example? Well, let's rewrite some of this code in a curried form or a partially curried form. So instead of taking all of our arguments in one go, our amount, our factor, and our base, we're going to rewrite it in a way that returns a double unary operator. So that's a function that takes an argument to double and returns a double. And our convert function is going to take in the factor and base and then return back that function from it. Okay? So we can use this to build together our temperature converter like this, and then we can call the appliers double method on our double unary operator with the value of 10 and convert it back to our Celsius number. Okay? Or sorry, our Fahrenheit number. The other thing that goes with currying is the eating of the curry. Now, these people here are doing a really, really bad job of eating their curry. You can tell that for two reasons. Firstly, they're not having fun, okay? Secondly, they're drinking wine whilst eating their curry. That's massively doing it wrong. Okay, what about the eating of our curried function? Well, that's called partial application. And partial application means you give it some of these arguments, which you can do to a function in curried form, without giving them all in one go. So what does that look like? Well, here's some partial application examples. We're applying some of the arguments to our convert functions. So our temperature arguments, our currency arguments, or our distance arguments. And in each case, we're getting back a function. So we still need to give it another argument to actually call it. Which we saw an example on the previous slide. It's possible to write more generic currying functions. So here's an example function that takes a function that's not in curried form and converts it to curried form. So its argument function has two integer arguments and returns one integer argument back. Okay? And that's the by function at the top, the int binary operator. And it returns a function that takes one argument and then returns a function that takes one argument that then returns an int at the end. So the way we'd implement that in code is we'd return a lambda expression that's got one argument f, and then the return value of that lambda expression is another lambda expression that takes the second argument, which is called s, and then once it's got all the arguments together, we can just invoke the function that we were wrapping up to begin with. So I've not shown a fully generic currying function because frankly the generics get increasingly horrible the more of this that you do, but I've given you an example of how you can do it for int functions, for example. And then you'd use that currying function like this. So here's an example function that takes two arguments, and our curried function is that add method, and then we can apply the first argument to it, which is 1, and then we can apply as int the second argument, which is 2, and then we'll get 3 at the end. So that's how we've broken up this application through currying, and then done partial application, feeding in the arguments one at a time. Okay? Currying is used quite a lot in functional programming, especially for things like parser, combinator libraries, templating, where you have these very, very generic libraries, and then you pass in some functions to get your more specific, domain-specific implementation, and then you pass in the specific values. So an example from for say, a parser would be maybe you have a generic function that says, eat me many of this character, and then you pass in a thing that says single space, and then you've got a function back that eats many spaces. Okay? So in summary, currying, this act of currying, is about splitting up the arguments of the function, very informally, and the partial application is the eating of those arguments one at a time, which we can do now we have a function in curried form. Okay? So, immutability. Well, let's start off with an example mutable object before we talk about mutability. And this is a train journey. And it's really a single step in a train journey. It's saying a train's going to take you from A to B. And each train journey step here has a price and some onward journey that we're going to go to afterwards. And we've got getters and setters for both the price and the onward journey. Very standard Java Pojo. We can give an immutable version of this function by changing it thus. So firstly, we have got our setters, and instead of mutating the state of our existing object by updating its fields, we're replacing them at the bottom with methods. So they return you a new object instead of mutating the existing object. And the other things we've done is we've made this class final, which means one of our colleagues can't subclass it and break our immutability contract. And we've also made the fields final. The fields final isn't necessarily required for an object to be immutable, but but it does guarantee the thread-safe publication of the object once it's been constructed, which is very useful if you want to make an object immutable because you want to make it thread-safe. Okay? So let's think about an example scenario of how we want to link together our train journeys to form longer journeys. Well, we've got this idea of our destructive updates because our train journey object really was acting a bit like a linked list. It had a reference to the next element in the list, and that would be our continuation, our onward journey. And if we wanted to have a destructive update, which is what we'd have to do for the mutable object, we'd return, we would update our onward journey to point to the continuation. And that's the kind of example code for what a mutable update would look like. We'd find the end of our journey, and at the end of our journey, we'd add the onward step. Okay? And then we might write some code like this, and this code looks completely innocuous, right? It looks completely safe, sane. We link together the start with our continuation, and then we do the exact same thing. And then we're going to call this visit method, which is going to loop over our journey, printing out the price of each step. But even though this code looks completely safe, completely innocuous, wasn't obvious what's wrong with it, if we actually run it, we get a Stack Overflow exception because we've accidentally re-linked this journey to itself and had the continuation pointing back to itself. So it's an example of a situation where by having a mutable state, it looked like we could have very, very simple, obviously working code that actually caused a fairly significant error in our code. The functional style of appending is, instead of updating that this onward journey, we return a new train journey. And by returning a new train journey, it means anything else that was referring to the old train journey won't have its states updated from underneath, won't have the rug pulled from under it. So that is an approach that would have stopped us from accidentally introducing this cycle in our train journey graph. And that's an example of how you would update your immutable train journey. We just link the onward journey, so we finally find the end of it, and then we return a new train journey with the start and the onward journey. Okay? So immutability, even though it's something which functional programmers are really keen on, is actually something which has also become increasingly popular in object-oriented circles as well. Is anyone here a fan of domain-driven design or use domain-driven design at all? A few people? Yeah, never quite as popular as I expect it to be. So domain-driven design is an approach that emphasizes the domain modeling in software engineering and splits up your big domain into several bounded contexts using events to communicate between them. And the value types that it uses for events are all meant to be immutable because you don't want to have these different decoupled components interfering with each other's state. A lot of the improvements in core Java libraries over the last release or two have started moving towards using more immutable objects and immutable value types. So there's a new date and time library in Java 8 and a new optional class in Java 8, both of which are immutable classes. And there's a value types proposal which is proposed to be introduced in Java 10, and the value types proposal suggests that every value type should be immutable. There's also a significant improvement in the amount of tooling you have, which tries to give you support for putting together these value types. So obviously the final keyword's useful, but it only bans reassignment. So you can still have a mutable object by assigning a mutable object into a final field. There's a spec for allowing more annotations all over the place, which gives you improved opportunity for static analyzers. And there's a GitHub project called Mutability Detector, which is very good for finding problems with your code that should be immutable. You can write a test that just says, assert this class is immutable. And then there's obviously find bugs, which is a static analysis tool, which if you annotate your class saying this should be immutable, it will go and check it genuinely is. The other thing to say is that immutability does have some downsides to it. It's not a complete panacea. a thing that you should always use without thinking. So, for example, by allocating new objects every time rather than just updating existing ones, you can increase your memory allocation pressure, which might introduce performance problems if you're doing it in a particularly performance critical part of your code. Sometimes it's harder to model problems with immutability than mutability. So an example of this might be you've got really big, deep object graphs and you only want to change a little bit down in a leaf node. Or maybe, for example, say a car simulation. If you're simulating the movement of a car around a racetrack, the functional approach would be to return a new car that's got everything else in the car exactly identical and just its x or y coordinates slightly different. And that's really a bit of an insane thing when you're just saying move this car slightly. So sometimes it just doesn't fit towards the type of problem that you're working on. Sometimes you have problems like ORMs don't necessarily like you or don't encourage you to have immutable value classes. Serialization's workaroundable, and most serialization libraries have a solution to that kind of problem these days. But they also used to be a problem. And obviously there's also the alternative to, instead of having a bunch of mutable state that's spread throughout your application, to have more isolated, localized bits of mutable local state, for example, kind of more actor-like approach. So in summary, when we're talking about immutability from a functional programming side of things, we're talking about reducing the scope for bugs in our software. So, the optional data type. Who's seen this guy in production at some point in time, the null pointer exception? Who's not putting their hand up at the moment? Do you actually program Java? Fantastic. So it's especially problematic when we see code like this. So we've got one line of code that says get the name of your car insurance provider, and we call get car on the person, and we call get insurance on the car, we call get name on the car insurance policy. And where is the null pointer exception? Was the person null? Was the car null? Was the insurance policy null? Who knows? This poor chap Wally got so confused by debugging this code that he went off and started hiding himself in large groups of people, rarely to be found again. So, one approach to seeing that kind of problem is a very heavy level of defensive checking. I'm sure people have seen this in code from places to place. Check everything's null, check everything's not null all over the place. And the problem with this approach is A, you don't know what should be null or what shouldn't be null, so maybe you're adding defensive checks where they're not really needed. And B, you end up with spending more time defensively checking for whether things are null than you do actually writing code. But Java 8 has an alternative solution to this kind of problem, which is the optional data type. So it's in the standard library at Java util optional. It's a generic type, so optional of T, and you can think of it as being like a container or like a collection, but that either has 1 or 0 values in. Okay? So it provides you explicit modeling. It says this value is either optional, it's either present or absent. And it's immediately clear to you that's genuinely optional. And that gives you better maintainability in the sense of it's easy to read your code, easier to see what's going on. The other thing is you need to actively unwrap that optional value. So this forces users to think about the case where it's a missing value. You've got to provide an alternative or do something to get you back to genuinely having a value. So let's look at an example of this. Let's update our domain model. So this is a very extreme case of use of optional, but we'll just run through it as a thought process. A person may or may not have a car, so that's going to be optional. The car may or may not have an insurance policy, so that's going to be optional. But we're going to say every insurance policy definitely has a name, so we know that if you've got an insurance policy, that class must have a name. Now, optional provides you a bunch of useful functions operating on it. So, for example, map is one of the functions you have on optional. And map says, here's a function. If there's a value in this optional box, apply it to that value. If it's absent, just return you the absent optional. So that means you can safely pull the name out of an insurance policy without having to do a null check. So let's try and update our example. And we're going to take our person, and we're going to use the of-nullable factory method to say, if this person is null, give me an absent optional. If they're present, give me an optional of person. And then we're going to map the person into their car, the car into their insurance policy, and the insurance policy into the name. Unfortunately, for this specific example, it doesn't work because our car returns an optional value for its insurance policy, and then you end up with an optional of an optional, and you're stuck in this confusing mess. I wonder if there's someone who can come and help us find out how to solve this problem. Fantastic. We've got a shout from the audience, but I've also got a Shiba Inu dog which is telling us the answer as well, so that's fine. So flat, such map, much optional, wow. So, whilst our map function worked on the value and returned a new value, our flat map function worked on the value and returned a new optional, and then just returns that optional itself. So, how does that look? Well, our getCar method that returns an optional of car, we flat map that. We flat map the car into an insurance policy if it's there or not. We map the insurance policy into its name, and if this insurance policy is missing, we can call the or else method, and that gives us a default value. So that says if it was missing, provide me a value, and then I've genuinely got a string at the end, and I've got no NPEs on the way down that chain. So this is obviously quite an extreme use of optional, where we've done it a lot, but it gives you an example of some of the different features that you have available with optionals. A comment on naming, Java 8 also has the stream API, and you can think about optionals as being like having a stream with only one element in. So this is how you would basically do the exact same thing. You could see the exact same flat map, map. There isn't an or else at the end on the stream. That's an error. But the map and the flat map have conceptually equivalent operations on both a stream and an optional. Optional and field. So this is one of those topics which is surprisingly controversial, often discussed. So I think most people are quite happy with the idea that you can have an optional returned from a method, from some operation that may or may not give you a value. But should it really be used for fields? It depends. So there are some pros on using optional for fields. If you've got that kind of getter and setter type modeling, you've got explicit modeling in the field as well as in the getter and setter. You've got null safe access to that field, and you can just return the optional as part of the getter. On the downside, because you've got all these values boxed up in optionals, you get a bit more indirection. So you've got another pointer chase to get to every field, and you've got potentially more GC overhead. These are problems which could be solved in Java 10 with value types. Or at the moment, not every library itself understands the optional component. And some libraries require you to have every field being serializable. For example, CDI does this. And the optional data type is not serializable. Okay? So, the takeaway from this section is really that our consistent use of optional replaces the use of nulls for representing situations where a value may be present or may be absent. Okay? So, let's just summarize the different benefits we've talked about by taking ideas from functional programming. The first-class functions allowed us to cope for requirement change, so we wrote more generic functions that took first-class functions as arguments. Currying let us split up the parameters of a parameter list, and then we could reuse logic within that function. Immutability reduced the scope for bugs by meaning that we didn't have state that was dangling around in different parts of our program. And optional data types let us reduce the null checking boilerplate and also prevent bugs by forcing us to think about and understand the cases where values might be missing or present. Okay? So, hopefully now we've moved to a more intermediate step. Maybe we're not going crazy with functional programming ideas. We brought in some of those functional programming ideas and talked about how we can use them in our day-to-day code. I'll give you guys an opportunity to ask some questions in a sec, but just to remind you, If you're interested, I do run a training course on Java 8, and obviously a book as well on that topic. On the left, there's my friend and also involved in the training business, Raul, has also written a book on this topic, also very good. And I've also started running online training courses through Pluralsight, which you can see at the top there. So that was the end of the talk. So thank you very much for listening. Thanks. If anyone's got any questions, I've got a free copy of my book, which I'll be giving to the person with the most interesting question. So if you've got any questions, feel free to fire away now.
Thank you for the session.
Thanks.
I would like to ask you, don't you think that currying is not still convenient in Java 8? And do you think that it can be added some new Java language syntax sugar for it?
Thanks, good questions. The question was, do I think currying is not convenient? I agree. Currying at the moment is not as convenient in Java 8 as it is in many purely functional languages, or I shouldn't say purely functional language, as in many idiomatically functional languages. It's not, but it's better than not having it at all, and it is useful for some situations. Do I think it can be added in a later release with better support? I think it's possible to add support for currying as a language feature in a future release. I suspect it won't happen, because I think if there was a desire to do it, it would have happened in 8, but never say never. I think it would be a good addition, but you know, it's kind of up to Oracle on that front, I'd say. Okay. Well,
actually, following up on currying, have you ever seen in a real code base the current approach being used?
Of the currying in a real code base? I have in plenty of languages. You see it all the time in things like Haskell and things like Scala. In Java, I think that it's not really a popular enough thing yet to see it all the time. I've done it myself in a real code base, so if that counts, then yeah, I've done it myself. So I have seen it at least once, but definitely not often.
Speaking of optionals, how about accepting optional as a parameter?
So the question is it okay to accept optional as a parameter? I think it could be okay to accept optional as a parameter. So I think a more common idiom in Java is to have an overloaded method where you either have the parameter present or not. And I think that's an idiom which is both familiar and also quite suitable for situations where there's one parameter that's optional or not. The scenario where that kind of falls down under is when you have like a lot of optional or default type parameters, and in that situation it might make more sense, but I wouldn't say go and use it willy-nilly. Okay?
My question, why optional is not serializable in Java 8?
Yeah, right. Yeah. So why is optional not serializable? So there was a lot of discussion about serializability during the Java 8 spec. There was a lot of discussion about whether lambda should be serializable. Serializability has a lot of issues. So the current version of serializability basically forces you to expose an implementation detail, the internal representation of your optional data type. And the reality is that hopefully in Java 10 there'll be value types, and in reality you want every optional to be a value type. It reduces the object allocation overhead, it reduces the pointer and direction overhead. A value type optional would be faster. And you'll see that there's this nice caveat in the Java doc on the optional data type saying, don't assume this object has identity, don't lock on it, don't use double equals, reference equals on it. This may change in a future version, it's not supported, specifically so you can allow it to become a value type. And serializability would just be another thing which made it harder to migrate to become a value type in a future version. So there's that kind of reason. There's also another aspect of it, which is serializability in Java is actually quite terrible in many respects. It has this kind of conception that any old Java object can be serialized, and goes really hard to try and make that possible. And the result is that you end up with a serialization format that's not at all compatible with dealing with other programming languages, and is not even very efficient despite it being a binary format. So serialization is actually quite terrible, and I'm quite happy they didn't do it, because I'd like to discourage more people from using Java's built-in serialization anyway. Okay, does that answer the question? Thanks. Any other questions?
Yep. Yeah, you have explained to us that we can chain function calls.
Yep.
And I've started to see that in some code bases.
Mm-hmm.
And people are chaining like a lot of function calls, which makes the code completely unreadable. What's your take on this, and how would you suggest to prevent this?
So I think there's two different... Thanks, that's a good question. So I think there's two different aspects of it. There's, are you chaining the function call willy-nilly, like if you got .get, which is the kind of thing which massively breaks the law of Demeter, right? If you've got a bunch of chained gets, you're ending up reading into the state, prodding into the internal implementation of other classes. And that's quite a bad approach. But is chaining method calls in and of itself a problem? Not necessarily. So when you see things, APIs, which are idiomatically designed to be method chained, so for example, the fluent builder pattern where you say with foo, with bar, I think that's fine to chain. If you see things like the streams API where you see a lot of method chaining, I think that's fine to chain. I think those kind of API styles, I don't view them as being hard to read. They're hard to read when you first see them, but I don't think they're hard to read, especially if you formatted it properly with a new operation on each line. That's perfectly fine. So I think there's that difference between good method chaining and bad method chaining. And if you see someone doing the bad method chaining, that's basically the same situation as any other bad programming practice, right? There's a lot of things that people do which aren't necessarily perfect, or shortcuts to ship things out the door, or what have you. And I think, that needs to be dealt with in just the same way as, you deal with your colleagues whenever they do something else that's bad. So, some teams are kind of more, have these kind of retrospectives or talk about code quality or that kind of thing. Other people do pairing, code reviews, whatever you do to try and improve code quality in general, I think applies equally to this type of thing as anyone. But I don't agree with the idea that it's always a bad thing. Is that okay? Thanks. Any other questions?
Yep. Do you think that using get method of optional class is a good way to extract the object from the optional?
Sorry, can you say that again? Do I think using a getter?
Yep, from optional.
Oh, the .get method call on optional. No. So it's definitely not a good idea for two reasons. Firstly, it can throw an exception. So you're basically back to the null pointer exception case. And secondly, it's a situation where what you've basically said is, I'm going to ignore the case where it's optional, which is the exact point of optional that you think about it. So I think it's only okay to use get if you absolutely know that it's optional, that there's definitely a value in that optional object, which is quite rare if it's genuinely optional. So it's very rare to actually use the .get call. We'll see over the coming years how frequently .get gets used, but as I said, optional provides a bunch of more idiomatic ways of dealing with the value map, flat map, or else, things like that, which let you deal with it in a way that's safe for the absent case. So I wouldn't use get if at all possible. Thanks.
Okay, thanks.
Any other questions? Okay, thank you very much.